ಈ ಮೊಬೈಲ್ ತಗೊಂಡ್ಬಿಟ್ಟು ಒಂದು ನಿಮಿಷ ನನಗೇನು ಗೊತ್ತಾ,
Yeah, sir, you can start now, sir.
Yeah, madam. Thank you. Good evening, students.
Good evening, sir.
Yeah. Now, in this today's session, we'll start up with the ray optics. Okay. Yeah. You can see the green color board.
Yes, sir.
Yeah. So this ray optics is going to come under in part 2 book. And in this ray optics, you are going to deal about the two important concepts. One is called the reflection method. The first method is called as what?
Reflection, sir.
Reflection. The second one is going to deal about the concept of refraction. So the second concept is the refraction. Under the reflection, you're going to deal about the two important concepts. How the reflection is going to take place in the case of a plane mirror. In the case of plane mirror. Second one, in the case of curved mirror. So in reflection, you are going to analyze how the reflection is going to take place in two different cases. One in plane mirror, the second one in curved mirror. In refraction, you are going to explain the refraction phenomena under plane surface, how the refraction is going to take place under the plane surface, then how the refraction is going to take place in the prism, then how the refraction is going to take place in spherical surfaces, and how the refraction is going to take place in the case of lenses. So in the refraction, you are going to explain the refraction phenomena for the four different cases. One is for plane surface, the second one is for the prism, the third one is for the spherical surface, the fourth one is for the lenses. Apart from this, you are going to analyze one more application of that. That is what we called as the optical instruments. The application of that is what we called as the optical instruments you are going to analyze. In optical instruments, you are going to analyze the concepts of two cases. One is for microscope. The second one is telescope. In microscope, you're going to analyze it for two cases. One is for a simple microscope. The second one is called compound microscope. So you're going to analyze the ray diagram for simple microscope as well as for the compound microscope. In telescope also, you are going to analyze the reflecting telescopes. Reflecting telescope and also astronomical telescope. So this is the phenomenon what exactly you are going to analyze in this ray optics chapter. So in ray optics, mainly you are going to deal under two important concepts, that is reflection. The second one is refraction. Under reflection, you are going to analyze for the two cases. One is for the plane mirror. The second one is for the curved mirror. Can you hear my voice, students? Hello, hello, students. Can you hear my voice? Are you audible?
Yes, sir.
Okay, okay. So in the refraction, you are going to analyze the four different concepts. How the refraction is taking place in plane surface, prism, and spherical surface, and in the cases of lenses. Under the application of this, we are going to analyze the important instruments. That is what we called as an optical instruments. Under optical instruments, we are going to deal under two concepts. One is called a microscope. The another one is the telescope. In microscope, you are going to deal about the construction, the principle, the ray diagram of simple and compound microscope. In telescope also, you are going to deal about the two cases, that is astronomical telescopes and the reflecting telescopes. Yeah. So this is the concepts what we are going to deal in ray optics. Now, in the today's session, let me explain how the reflection is taking place in the case of a plane mirror. So today, what is our concept, students? Today we are going to deal about the study of what? Reflection phenomena, sir. In which surface? In which mirror?
So plane mirror.
In the plane mirror. Okay. Yeah. Yeah. Can you see the white color page on that green color board?
Yes, sir.
Okay, good. Yeah. So first, what we are going to deal? Reflection of light. What is the meaning of this reflection of light? Suppose if I considered a plane mirror means one surface is polished where the ray of light cannot pass through that. This is called as a plane mirror. In this plane mirror, I'm going to incident a ray of light. I'm going to incident a ray of light. What is that ray called? PQ. What is this PQ called? What is that PQ called?
Incident ray.
Very good. Incident ray. Now, whenever the ray of light is incident at the point Q, you can drop a perpendicular line, students, at the point Q. I'll call that as Mn. This Mn is called as the normal. What is that Mn called?
So normal.
Yeah, it is a normal. Normal means always you have to draw a perpendicular line to the mirror. Then there is an angle made by the incident ray with the normal. The angle made by the incident ray and the normal is denoted with small I. That I is called as angle of incidence. What is that I called?
It's the angle of incidence.
Angle of incidence. Now, whenever this ray of light is incident, now this ray is going to bounce back to the same media. It will come back to the same media. This QR is called as reflected ray. What is that QR called?
So reflected ray.
QR is called reflected ray. And the angle made with the normal and the reflected ray is denoted with R. That R is called as angle of reflection. Angle of reflection. So what is the meaning of reflection, students? Whenever the ray of light is incident on any surface, if it comes back to the same media, what is that phenomenon called?
It's a reflection.
Yeah, it is called the reflection of light. So see here, whenever the rays light is incident, it is coming back to the same media. It is coming back to the same media. What is this phenomenon called? Reflection of light. Please remember, whatever the angle of incidence is there, that should be equal to the angle of reflection. Angle of incidence is always equal to what?
It's the angle of reflection.
Yeah, that is the basic law of reflection, students. So whenever the ray of light is incident at an angle of incidence I, the ray will reflect back to the same media at the same angle. So please remember, in the reflection phenomena, angle of incidence is equal to what?
It's the angle of reflection.
Yeah, angle of reflection. And one more thing, whenever the ray is going to reflect back to the same media, please remember, velocity, wavelength, and frequency of light will remain same, but only the intensity will decreases. Only the intensity decreases. So in the reflection phenomena, which parameter decreases? Which quantity will decrease in the reflection phenomena?
Intensity.
Intensity. But please remember, velocity, wavelength, and frequency will remain
It's the same.
same. Please remember that, because they may be asked the question in competitive level. Yeah. Second thing, if the ray of light is incident normally, for example, if I say this is the mirror, this is the normal, right?
Yes, sir.
Now the ray of light is incident along the normal only. Then how the reflection should be? Angle of reflection should be same in the opposite direction. So whenever the ray of light is incident along the normal, the ray will retraces the same path. In this case, can you tell me what is angle of incidence?
It's a 0 degree, sir.
Very good. 0 degree. So if angle of incidence is 0 degree, what should be the angle of reflection?
It's a 0 degree.
0 degree. This is the principle. So if I is 0, R should be 0. I think you got this concept, right?
Yeah.
Yeah, fine. Now, after knowing this basic phenomena, you must know the concept of the real and virtual images. Real and virtual images. Look at this. This is the mirror. This is the mirror. Okay. I'll keep the object here O. What is O represents? What is O
Object.
represents?
Object.
Object. Now I'm going to incident a ray of light like this. Like this. Now the image is going to be formed. The image is going to be formed somewhere here. Let it be I. I is called as real image. I is called as what? Real image. Suppose if the image is formed somewhere here, I dash. If the image is formed at I dash, this is called virtual image. This is called as virtual image. Look at the difference, students. If the image is formed on the same side of the object, if the image is formed on the same side of the object, then it is called as a real. If the image is formed on the other side, other medium of the object, then it is called virtual image. So on the same side of the object, if the image is formed, what is that called?
It's a real image.
Yeah. If the object is placed in one medium and the image is formed in the another medium, then it is called
Virtual image.
virtual image. You got my idea?
Yes, sir.
Yeah. See here. This is mirror. This is mirror. Object is placed here. Object is placed here. For this object, I'm getting the image somewhere here. I'm getting the image here. Can you tell me it is a real image or a virtual image? Hello, can
It's
you
a
tell me
real
it is a
image,
real
sir.
image or a
It's a
virtual
real-
image?
Real, sir.
Why it is real image?
Sir, it is formed in the same medium, sir.
Yeah, on same medium is on the same side of the object.
Yes, sir.
Okay. Suppose if the image is formed somewhere here, I mean to say like this here.
So virtual.
Yeah. So this is virtual image. This is real image. So you got an idea how to tell the real image and the virtual image, right?
Yes, sir.
Okay, good. Yeah. Come to the next concept, students. That is about the concept of the deviation. About the concept of what?
So deviation.
Deviation. Look at the concept like this. If this is a mirror, the ray is like to be incident like this. This is the normal. What is this called? I?
It's an angle of incidence.
The ray will reflect back like this, right?
Yes, sir.
What is this angle called?
It's an angle of reflection.
Yeah. Now, if the mirror is not there, suppose if the mirror is not there, Mn. If mirror Mn is not there, how would be the ray PQ is going to travel? If
So
the mirror
pass
Mn
straight,
is
sir.
not there, how the ray PQ would travel?
So straight, sir.
Very good. It travels straight. Very good. It will travel straight. Because of the mirror, instead of traveling along Q dash, it is traveling along Q to R, right?
Yes, sir.
Then this angle we call it as a deviation. This is called deviation. So what is deviation? Deviation is the angle between the incident and the reflected one. This angle. You can prove that the angle of deviation is always equal to what?
So 180 minus 2i.
Yeah. Angle of deviation is always equal to 180 minus 2i. 180 minus 2i. Example, suppose if I incident a ray of light at 30 degree, can you tell me what is the deviation for this case? The ray would like travel like this. This will be the incident ray direct. This is called delta. What is the deviation angle?
So is it 90 degrees, sir?
Why it is 90, appa? What is the formula you have?
So 120 degree?
Yeah, 120 degree. Good. What's the formula for deviation?
So sorry, sir. Calculation mistake. 180 minus 2i.
Yeah, deviation is 180 minus 2i. I is equal to what?
So 30.
Yeah, 2 into 30.
Yes, sir.
60, right?
Yes, sir. 120, sir.
So what is the deviation then?
120 degrees.
Yeah, this is what the angle of deviation. So please remember, for the case of the plane mirror, if the incidence is I, then what is the formula we have to find the angle of deviation?
So 180 minus 2i, sir.
Yeah. Remember the second case. Now the second case is talking about the two plane mirrors. There is no single mirror. There is two mirrors here. This is one mirror. This is the another mirror. The two mirror are separated by what angle? What is the
So
angle
theta.
between the
So
two
theta.
mirrors? Theta. Then for this case, the deviation is always given by 360 minus 2 theta. 360 minus?
2 theta, sir.
Yeah, 2 theta. Please be very careful, students, here. In this case, the angle of deviation does not depend on angle of incidence. When two mirrors are inclined by an angle theta, deviation is given by 360 minus 2 theta. It doesn't depend on angle of incidence. Even if you incident the angle at 10 degree, 20 degree, 30 degree, 40 degree, for irrespective changes in the angle of incidence, the deviation will not change. So the deviation will remain same. So what is the deviation?
So
360 minus
2
2
theta.
theta. Yeah. Shall I give that one more example? If I say this is one mirror, this is the second mirror. This theta, I'm going to give it as 60 degree. What is the angle of deviation if the two mirrors are inclined by 60 degree?
So 360 minus 120, sir.
How much it
So
is?
240.
Yeah. So what is the angle of deviation?
240, sir. 240
Yeah.
degrees.
Yeah. So in the second case, please remember, angle of deviation is not depend on.
So the angle of incidence, sir, it does
Yeah.
not depend on the
If you
angle.
incident at 30 degree, or if you incident at 60 degree, or if you incident at 90 degree, it won't matter. Angle of deviation will remain same. Okay.
Yes,
Have
sir.
you got my point?
Yes, sir.
Okay. Okay. Next one, very important, Appa. 2 to 3 times they have asked the question based on this concept. Okay, in the competitive questions in the NEET level. Suppose if I say this is the mirror. This is the position of the mirror, Mn. Okay. Now this is the incident ray. This is the reflected ray. Okay. Now I'm going to tilt the mirror by an angle theta. Mirror is tilted by what angle? Theta.
So theta.
Yeah, mirror is rotated by what angle? Theta. Then please remember, this reflected ray is going to shift to new position, but please remember the angle is 2 theta. If the mirror is rotated by an angle theta, reflected ray will rotated by what angle? If mirror is rotated by an angle theta, reflected ray is rotated by what angle?
So theta, right, sir?
2 theta, 2 theta. It is not theta, it is going to be the twice of that. Remember that concept. No need to prove that. By simple geometry, you can prove that. By simple geometry, you can prove that. You can look at this figure. In this figure, by using your normal algebraic and geometrical concepts, you can prove that. So if the mirror is rotated by what angle?
So 2 theta.
Theta. The reflected ray will get deflected by what angle? 2 theta. Please remember this. Yeah. Coming to the images formed. The number of images formed by the plane mirror. Suppose if one mirror is there, if I say this is object, there will be one image will be formed. One image will be formed. One object. How many images? One image. So if one mirror is there, one object, how many images will be formed?
So one image.
If plane mirror, single plane mirror is there, for single plane mirror, there will be one object, there will be one image. Suppose if two mirrors are there, if two mirrors are there, if the two mirrors are makes an angle theta, then number of images will be always equal to 360 by theta minus 1. What is the number of images formula?
So 360 by theta minus 1.
Yeah, please remember, number of images formed by the two plane mirrors is equal to 360 by theta minus 1. Look at the condition for this case, students. If 360 by theta is even integer, you have to do by minus 1. Suppose if it is 360 by theta is an odd integer, you have to keep n is equal to 360 by theta if they are unsymmetry. If they are symmetry, then 360 by theta minus 1. 360 by theta minus 1. If the object is placed symmetrically, then keep the formula 360 by theta minus 1. Only if it is unsymmetry, you have to go with 360 by theta. Usually this is a very rare cases they are going to ask in the exam. Usually the problems will be based on 360 by theta minus 1 only. In NCERT, we have only the symmetrical case. We don't have this asymmetrical case. So what is the formula we have to find the number of images? What is the formula we have to find the number of images?
So 360 by theta minus 1.
Yeah. Look at these three different cases, students. If the angle theta is 0, andre, I mean, the two plane mirrors are parallel to each other. If mirrors are parallel to each other, then angle theta is equal to what?
So 0.
0 degree. How many number of images will be formed?
Sir, infinity, sir. Any number
Infinity.
divided by
Because
0 is
n is equal to 360 by 0 minus 1. What is 360 by 0?
Sir, infinity, sir.
Yeah. So what is the number of images?
Sir, infinity.
Infinity. If theta is 90 degree, can you tell me how many images will be formed?
So 4 minus 1, 3, sir.
Yeah. 360 by 90 minus 1. That is how many images?
Sir, 3.
3 images. You got my point?
Yes, sir.
Related to this, can you tell me the answer for this problem? Can you read the problem for me?
Sir, first one, sir, plane mirror makes an angle of
No. Second one, which
Second
I
one.
take with the red
Yes,
color
sir.
one.
A person is in a room whose ceiling and 2 adjacent walls are mirrors. How many images are formed?
Yeah. You know that in the room, if I say this is ceiling and the adjacent walls are this. These two are the adjacent walls. This
Yes.
is the ceiling. Okay. So how many
Yes,
plane
sir.
mirrors are there?
So 3, sir.
This is ceiling. This is wall 1. This is wall 2. Okay. Now, a person is standing in a room. A person is standing in a room. Can you tell me how many images will be formed in this case? Look at the problem. A very interesting one. Can you tell me how many images will be formed?
So I'm not sure, but is it 6, sir?
6?
Yes, sir. I'm not sure, sir.
Okay. Do one thing. Now, let us forget about the ceiling, Appa. Let us forget about the ceiling. Let us keep only the two walls. This is the object. What is the angle between these two plane mirrors?
Sir, 90.
Yeah. If it is 90 degree, how many images will be formed?
So 3 images.
360 by 90 minus 1, no.
Yes, sir.
Why I am using theta as 90 degree?
Sir, because the angle between the two plane mirrors is 90, sir.
360 by 90?
So 4.
4 minus 1?
3, sir.
So for these two walls, this is image, this is image, this is image. I1, I2, I3. So totally how many images are there?
3, sir.
3 images for this object. Now, if I consider the ceiling now, if I consider only the ceiling, can you tell me for the ceiling, how many objects are there?
So 1 object.
A, 1 object, real object. But
Yes,
3
sir.
images
So
will be there,
virtual
no?
object, 3 virtual objects, sir.
Yeah, very good. So totally how many objects will be there for ceiling?
So 4 objects.
Yeah. Ceiling is a single plane mirror, right?
Yes, sir.
So 4 objects are there. So how many images will be there?
Sir, 4 images.
Yeah, 4 images will be there. So this is the real object, right?
Yes, sir.
These 3 are the images actually. And these 4 are the images. So all put together, if I put all the 3 mirrors together, how many images you got?
Sir, 7, sir.
Very good. Very good. I think it's a tricky, right?
Yes, sir.
So if there are 3 walls which are perpendicular to each other, if a person is there, how many images are going to be formed? I'm not putting a very simple question, direct question. If I just ask 2 mirrors are perpendicular to each other, what is the number of images? I think you can tell the answer.
Yes, sir. 3, sir.
Yeah. So if the ceiling is also attached to the mirror, how many images will be formed?
So 7.
Yeah, 7. You got my point?
Yes, sir.
Yeah. If you have any doubt related to this problem,
No, sir.
you have any doubt related to this?
No, sir.
Okay, very good, very good. Yeah. Similarly, you can analyze the first problem. Let me analyze the first problem. Can you read the question for me?
So a plane mirror makes an angle of 30 degrees with horizontal. If a vertical ray strikes the mirror, find the angle between mirror and reflected ray.
Yeah, yeah. Now, please try to put the diagram for this case, my dear students. There is a plane mirror. There is a horizontal line. What is the angle between them?
So 30 degrees.
So, can I analyze the problem like this? This is horizontal. This is mirror. What is the angle here?
So 30 degrees.
Okay. How the ray is incident?
So vertically, sir.
Vertical ray is incident. So if I say this is the normal, what should be this angle then?
So
30 degree, no?
Yes, sir.
This is horizontal, this is vertical. If horizontal is tilted like this, vertical in tilt agbekalva?
Yes, sir.
If horizontal is tilted by 30 degree, vertical line is also tilted by.
30 degrees, sir.
Then this is the reflected ray. This angle is also equal to 30 degree.
Yes, sir.
Because the angle of incidence is equal to angle of reflection. Angle of incidence is equal to.
It's angle of reflection, sir.
So 30 degree is that. So this is also 30 degree. What they are expecting?
Sir, angle between the mirror and the reflected ray, sir.
This is reflected ray, this is mirror. They are
Yes, sir.
expecting
So
this
60
angle.
degrees, sir. 60 degrees.
Very good, very good, very good. Good, good. So what is the angle between the mirror and the reflected ray?
So 60 degrees.
60 degree. Are you getting the questions?
Yes, sir.
Okay, okay. If you have any doubt related to this, you can ask Appa. Feel free to ask the doubts. It
No,
must
sir.
be like a discussion session.
No, sir. No doubt, sir.
Okay. Now, can you analyze this problem for me? That is the fifth problem. Yeah, anyone can read me the problem for me?
So a ray of light reflected successfully from two plane mirrors inclined at a certain angle undergoes a deviation of 300. The number of
Yeah.
images observable are.
So deviation is given 30 degree, 300 degree, right?
Yes, sir.
Number of images they are asking n.
Yes, sir.
Yeah. What is the formula we have to find the number of images, Appa?
So 360 by theta minus 1, sir.
But we don't know theta, my dear.
Sir, but deviation will be 360 minus 2 theta, right, sir?
Very good, very good, good, good. So deviation is 360 minus 2 theta. What is the deviation they have given?
300, sir.
So 300 equals to 360 minus 2 theta, or 2 theta will be 360 minus 300, right?
So theta is 30 degrees, sir.
Very good, Appa. Good, good. Now, how many images will be formed? 360 by 30 minus 1. Yes, fast. Tell me the calculation.
So 11.
11 images, no?
Yes, sir.
Yeah. Are you getting the problems?
Yes, sir.
Yeah. Good, good. So this is how we have found the number of images, students. Yeah. Let me solve the third problem here. Yeah. How many mirrors are there?
So 2, sir.
Yeah, one mirror I will call it as P, the another mirror is Q upper. P and Q. Okay. They are parallel as shown in the figure. A ray of light is incident at what angle?
Theta.
At one end A. The ray of light is incident at one end A. The plane of incidence coincides with the plane of the figure. The maximum number of times the ray undergoes reflections. Look at the diagram. This is one reflection, second reflection, third reflection, fourth reflection, fifth reflection. So this is the n number of reflections is taking place. We don't know how many number of reflections is taking place, right?
Yes, sir.
Yeah. We don't know how many number of reflections are going to take place. Assume there are n number of reflections. N number of reflections is taking place. Now I will assume for one reflection the distance is x. For one reflection, what is the distance?
So
X. So what is x? Horizontal distance for how many reflection?
So 1 reflection.
For one reflection. Now, can you tell me, Appa, how many reflections are taking place here totally?
So n, sir.
So L should be equal to n times of x.
Yes, sir.
For one reflection, the distance is x. For n number of reflection, the total distance is given as L. So L is equal to what? Nx.
Same.
Yeah. If I say this is also theta, can you tell me what is tan theta from the diagram? This is given D. What is tan theta? Opposite
So
by
x by
adjacent,
d,
no?
sir. So x by d.
Yeah. What is x then?
So d
Cross
tan theta.
multiply.
D tan theta, sir.
Yeah. So n is equal to L by x, no?
Yes, sir.
So L by. What is x?
So d tan theta.
So how many reflections, how many number of reflections it can undergo?
So L by d tan theta, sir.
Can you tell me which is the right option?
So option A.
Option. Any doubt related to this?
No, sir.
Yeah. Good. So you have studied about the concepts of this thing. What is that? Reflection, really virtual images, deviation concept, and number of images concept. Now, come to the last concept related to the mirror, Appa. That is, suppose if I keep the mirror here, mirror is at rest. If you stand in front of the mirror, suppose if you stand in front of the mirror, this is the object. Image will be formed here. Suppose if you move in front of the mirror, if you move towards the mirror, how the image is going to move? How the image will move?
So away
Practically,
from
you
the
think,
mirror.
Appa, if you move towards the mirror,
So
the
away from
image
the
of
mirror, sir.
the image is also going to move towards the mirror, right?
So won't it be away, sir?
The image is also move away from the mirror. You can try that at your home, no? If you just stand in front of your mirror and you just move towards the mirror, image also will come closer.
Yes, sir. Yes, sir.
Yeah. If the object is moving at the speed u, image is also moves at the same speed apart. With what speed?
You, sir.
U. This is the first case. But please remember, if the mirror is moving with the speed u, image speed will be double. Image speed will be what?
Double, sir.
Double. Please remember, image speed will be double. If the mirror is moving, image speed will be double. Looking for this, can you analyze the fourth problem for me? Can you analyze the fourth problem for me?
So is it 2V, sir?
Now there is a plane mirror, right?
Yes, sir.
Persons are moving towards each other. With what velocity?
So V.
One is plane mirror, the another one is person. They are moving towards each other. Can you draw the diagram for me? This is mirror. This is person. This is image. Okay.
Yes, sir.
Yeah. This is person. Now the person is moving with what speed, my dear?
So V, sir.
Mirror is also approaching towards that with what speed?
So V.
V, right?
Yes, sir.
Yeah. With respect to person, what should be the image speed?
So V.
If person is moving with V, image has to move it.
V, sir.
With respect to mirror, mirror is moving with V, so image has to move it.
So 2V.
2V. So what is the total speed of the image?
3V.
Total velocity is 3V. Yes. You got it?
You got it?
Yes. You have any doubt in this?
No, sir. No doubts.
Yeah. Okay. Related to this, you have to remember one more two concepts apart. Now, for example, you are standing in front of a mirror. You are going to stand in front of what? A mirror. Suppose if you are a height h, what is your height? H. If you stand in front of a mirror and if you want to view your complete image, if you are if you are standing in front of a mirror of height h, in order to view your complete image, in order to completely view your image, the minimum height of the mirror must be h by 2. What must be the minimum height of the mirror?
So H by 2.
Yeah. Suppose if your height is 40 centimeter, to get a complete image of your height, what should be the minimum mirror height? Suppose a person of height 40 centimeter is standing in front of a
Sir,
mirror.
20, sir. 20.
What should be the minimum height of the
Sir,
mirror to
20
get a full
centimeter.
image?
So 20 centimeter.
Yeah, 20 centimeter. That is the concept. Okay. Now, Suppose if I say this is a room, this is a room. Now, a person is going to stand. A person is going to stand at the middle of the room. And I'm going to place one mirror on the one side of the wall of the room. Now the person has to view the complete wall which is behind him. A person is standing in the middle of the room. Now he has to get the complete image of the behind wall, the wall which is behind him. The wall height is h. The minimum height of the mirror must be h by 3. What should be the minimum height?
H by 3, sir.
Yeah. If the person wants to see the complete image of the wall which is behind the person, behind him, the minimum height of the mirror must be h by 3. To get the complete image of the person itself, what must be the minimum height?
Sir, H by 2.
H by 2. Please be very careful. So a man of height h requires a mirror of length. The minimum least length of the mirror must be h by 2 to get the complete image. To see the complete wall behind himself of a person, what must be the minimum height of the mirror?
H by 3, sir.
That is 1/3 of the height of the wall. But remember, the person has to stand at the middle of the room. The person has to stand at the middle of the room.
Yes, sir.
Got it? Yeah.
Yes, sir.
This is the basic related concepts of plane mirror, Appa. Let me ask one question related to this. Let me see how you are going to solve it. This is plane mirror. This is the clock. This is the clock. 12, 3, 6, 9. This is 1, 2. You know that 4, 5, 7, 8, 10, 11. What is the time now? What is the time in this watch?
So 120.
No, 2:20. This is 2. Okay, sorry. Between 1 and 2, if you say it is 120. Okay, fine. It is 120. Now, if you see the image of this clock, can you tell me what is the time in the image?
So 10:40.
Very good. Very good. 10:40. Yeah. Very good, Appa. Very good. 10:40. So in order to get the time in the image, please always subtract with 11 hour 60 minutes. 11 hour
60 minutes, sir.
Yeah, 11 hours 60 minutes. In 60 minutes, if 20 minutes gone, 40, 11 minus 1, 10. So 10:40 is the time in the image. Got it?
Yes, sir.
Yeah. You have any doubt related to this, you may ask Appa. You feel free to ask.
No, sir, no doubt.
So this is about the reflection of light, only in which case?
So plane mirror.
Yeah, still we have to learn the reflection in
So spherical surface.
Yeah, curved mirror. Curved mirror. Curved mirror, Ali, there will be two types. One is concave mirror. The second one is
Convex, sir.
convex mirror. Concave mirror and the convex mirror. So that we will take up in the next session. Okay.
Yes, sir.
Please try to solve some more few questions related to plane mirror. If you have any doubts or queries related to that, you just ask in the next session. We'll clarify all those things. Okay. So no doubts, no, in the today's session?
No, sir.
Okay, pa. Then let me continue in the next session. Thank you.
Thank you, sir.
Yeah, thank you. Bye-bye.
Thank you, sir.
Thank you.